Before the hospital wakes, a technician rests a gloved hand on the glowing MRI console. It looks ordinary, but it reads the quantum spin of hydrogen atoms in a human body. Almost nobody thinks of it as quantum, not even the doctors who use it daily. So hold 5 questions in the dark with her. What is quietly making batteries charge faster while you sleep? What did a rover find in 3 billion-year-old Martian clay? What did a robot decide alone? How did a sensor catch a diagnosis years before doctors could? What's strange about the chip in your pocket? No answers yet, just the questions. Here is the rule underneath all of them. Technology does not arrive in a single day. It gathers quietly through 100 ordinary lab Tuesdays until one of them finally reaches you. Real names, real institutes, real dates, every fact checkable, no hype, no fear. Real labs, real people, documented facts, and the machine finally explained. The scanner finishes its warm-up cycle with a soft chime, and the first of those quiet Tuesdays is about to reach you. In a lab tucked between Adelaide and Brisbane, a physicist watches a row of tiny cells sip charge in unison. For years, her team has chased a strange idea called superabsorption. You link many small, light-absorbing molecules so they all fill at once instead of one after another. Ordinarily, a bigger battery charges no faster, but here the rule bends. In small demonstrations, packing the cells closer together changed how the battery filled. The more cells that joined in, the faster the whole thing charged, roughly in proportion. Picture 100 people filling a pool through a single hose, finishing quicker than one person alone. Still, just a benchtop promise. But the trick underneath it is oddly familiar. The same quantum spin your MRI scanner reads to see inside a body is, in this lab, quietly learning to hold a charge. No wonder the tech press floated the dream of a phone charging in the time it takes to blink. Nobody there promises that yet. What they have is smaller and stranger. A battery that charges itself faster the bigger it gets. Still early, still lab-bound, but real. And 3 billion years away, another instrument found something this same physics cannot yet explain. A rover parks its wheels over pale Martian clay and lowers a tiny drill. Inside its belly, a chemistry set no bigger than a microwave heats a smear of dust and reads its light. And in one of those signatures, a scientist back on Earth notices something she cannot quite explain. Locked in that clay sits a molecule shaped like the oldest known ancestor of DNA. The reading points to a thiophene-like organic compound locked in the clay. Nobody there calls it life, so the team weighs every word. This sits at the edge of the credible, not past it. Such organics can form with nothing ever alive, but the signature is real, and it will not go away. The same principle lets a machine read faint signals across a gulf of space. Both instruments do one thing: listen for a signature and read what the light or the spin comes back saying. One instrument listens to a body, the other listens to a world. Nobody knows yet what that molecule means, but on a warehouse floor, a machine just decided something on its own. A box rolls down the conveyor with one corner crushed inward, and a machine looks at it. Nobody wrote a rule for this exact dent, but the system pulls the box aside anyway, flags it, and routes a fresh one to take its place. That small choice, made without a rule for it, is the story. These newer agentic systems weigh a situation and decide what to do next. That kind of judgment call used to need a person watching every box. That same weighing, scaled up, is starting to help chemists narrow which molecules to test first. Some fear a jobs apocalypse. This is quieter, machines sensing before they act. And the same sensing turned inward is about to get very personal. In a Minnesota clinic, a sensor console is already watching for a signal no scan has found yet. In a shielded room outside Minneapolis, a researcher watches a needle that never quite holds still. The instrument beneath her hands is a quantum sensor, tuned to notice one electron flip its tiny magnetic direction. Your heart and your brain leak faint magnetic whispers with every beat and every thought. The scanners we have now mostly miss them. This one is built to listen. Line up quantum states delicate enough, and one electron's flip leaves a visible mark. A sensor this sensitive might one day catch conditions years earlier than any scan we have now. But the work is early stage, and scientists here choose their words with care. You have met this machine before. It is the same MRI scanner, a decade more awake. The one it might warn is anyone, someday even you, sitting right here. That earlier warning lives inside a scan file, waiting on a server somewhere, and the quiet fight to keep every scan, every message, every record safe from a future machine is already underway. Every scan like it now gets locked behind a wall built to outlast tomorrow's fastest computer. In August 2024, U.S. standards officials finalized new encryption rules. Federal systems must adopt them, and industry is already following. They were built specifically to survive future quantum computers. It is a quiet infrastructure shift, already rolling out underneath the apps on your phone. You never asked for it, but the lock on your messages just got quietly replaced. But the chip in your pocket hides a stranger answer than the lock ever did. To carve its circuits, a machine fires light so sharp it only exists because someone solved quantum mechanics first. Get that physics wrong, and the phone in your hand never boots at all. The same physics your scanner uses to see inside a body is here the reason the machine even exists. A small light returns here on a server rack, guarding data instead of diagnosing a body. The same quiet indicator you first met on the scanner. The battery, the clay, the warehouse, the scan, the lock, each hummed quietly on its own. One image is about to gather them all. Later, in the same radiology wing, the same technician rests her gloved hand on the same console. But every question that opened this story now has a name, a lab, and a date standing behind it. The battery charging while you sleep has physicists in Adelaide and Brisbane, still early, still real. The Martian molecule still has a team refusing to call it more than it is. The warehouse robot that chose on its own, the early diagnosis, the lock in your pocket, each has an address now. That box sorting system still weighs every parcel, still trimming the error rate, quarter after quarter. That is the whole thesis, said plainly. Progress is never a single headline. It is 100 quiet Tuesdays in a lab until one of them reaches you. No lone genius did this. Roughly 40 countries now run national quantum programs. They treat the field like an earlier generation treated the space race. Steady work, not one dramatic launch. So the woman touching the console is not a bystander to the future. She is already running it. And you? Where have you already stood beside quantum physics without knowing it?